So welcome back, Abafundi. Nice to see you all, and we are carrying on with our study of trigonometry. We are going to dive straight back in. We're busy with solving some trig equations. So let's have a look now at this one. So remember, the normal thing is for each trig ratio to take on a value twice per 360 degrees. In other words, we would expect two solutions per 360 degrees. Now tan half theta, what that half is going to do, it's actually going to stretch our graph out. So this means that we will get, remember, tan theta over 2 is exactly the same as tan half theta. What this means is we will get half as many graphs as usual. Half as many graphs as usual. And that means that we will in fact get half as many solutions as usual, right? So half as many solutions as usual. So normally we get 2 per 360 degrees. Now we're only going to get 1 per 360 degrees, right? But let's see how many rotations have we got here. From minus 360 to 360, we've actually got 2 rotations. So we're actually going to expect 2 solutions. If it was tan theta, we would get 4 solutions, 2 per rotation. Now we only get half as many. We're going to get 1 per rotation, so a total of 2. Right, now we're going to solve this. And so the first thing we do, once we've got our ratio on its own, which we have equal to a number, we find our key angle. And remember the key to finding a key or a reference angle? I like to draw a little picture of a key. Undo tan. And we wouldn't put the negative value into the calculator if there was a negative value. I'm just going to write a positive there, and I'm actually going to highlight that because that's really important. We just put the positive value in. Okay. Right. Now, what we get here, this happens to be a special angle. We get 60 degrees. The next thing we ask ourselves is, well, which quadrants do we want to be in for tan to be positive? And the answers are here and here. I'm actually going to just draw this picture a little bit bigger, right? Because there's something quite important that happens here with tan, which we just want to show you. Okay, there. Right, so we want to be in this quadrant and this quadrant. One of our angles is going to be over here in quadrant 1. Okay, that's just going to in fact be our key angle, or 60 degrees. The other angle is going to be here in quadrant 3. Okay, and it's actually going to be 180 plus our key, or 240 degrees. 180 plus the key. Okay, and I think you can see that these are vertically opposite angles. So the solutions for tan will always be 180 degrees apart. That means that for tan, we can actually, instead of having both these solutions, we can just take one of the solutions, so 60 degrees, that's our key angle, plus 180k, right, with k an integer. Because remember that when we add 180, we will actually get the quadrant 3 answer. When we add 180 again, we will get the first repeat of the quadrant 1 answer. When we add 180 again, we'll get the first repeat of the quadrant 3 answer. Does it make sense? It always makes sense. Okay, so we know that. Right, now what we're going to do is we're going to multiply everything through here by 2. And we get theta is 120 degrees plus 360k. Okay, that is a general solution. Now we want the specific solutions from minus 360 to 360. So if k is 0, then we get 120. If k was 1, we would get 120 plus 360, would get 480. That is a solution, but it's not a solution on this domain. So that's the only option so far. But if k is minus 1, then we get another answer, right? We get 240 degrees, right? Negative 240 degrees. 120 minus 360, negative 240 degrees. If we subtract another 360, we will go outside the bottom end of that range. So those are the two answers to this particular equation. And remember, we said right up front here, we said that we were expecting two answers to this equation. Okay, and those are they. So the big takeaway here is that with tan, we can add 180k to one of our solutions. With the other two ratios, sine and cos, we need to have both the standard solutions and we add 360k to each. Right, we're going to ask you to pause the video and we're going to ask you to try the questions on page 14. All right, and we're wanting a general solution. Sorry, not the questions on page 14, question number 14 on page 124. Okay, so dive into those, have a go. When you've tried them, let the video run again. Okay, so this first one, cos theta equals negative 0,3. The first thing we're going to do is we're going to find a key angle. And remember, the key to finding a key is we are going to undo cos of positive 0,3. We do not put the negative into the calculator when finding a key angle or reference angle. Okay, and there we go. Our reference angle or our key angle is 72,5 degrees. Okay, so 72,5 degrees. Then we ask ourselves, which quadrants do we want to be in? And now remember, we're talking here for cos being negative. Cos will be negative in quadrant 2 and quadrant 3. Remember, we only use our horizontal axis to get into these quadrants. So in other words, our one answer is going to be 180 minus 72,5. It's going to be 107,5 degrees. That's 180 minus 72,5. And the other one is going to be 180 plus 72,5. That's going to be 252,5 degrees. To each of those, we can add 360. Okay. And that there is our general solution to that equation. All right, fairly straightforward one. There it is, k is an element of z. Okay, don't forget to write k is an element of z. Okay, let's look at B. Okay, so sine theta over 4 is a half. All right, so the first thing we're going to do, we're going to find our key. All right, we're going to shift sine, undo sine of a half. And we get 30 degrees. Okay, and this time we want to be in quadrant 1 and quadrant 2 for sine to be positive, positive a half. We get into quadrant 1 by just going 0 plus our key. All right, so we get 30 degrees plus 360k. And we get into quadrant 2 by going 180 minus our key, 150 degrees. Plus 360k. Now that's not our angle. That is theta over 4. Each of these is theta over 4. Now we get theta by multiplying both sides by 4. And we get theta is 30 degrees. When we multiply 360 by 4, we actually get 1440k. And when we multiply 150 by 4, we get 600 plus 1440k. Okay, now what I quite like to do, all right, k is an element of z. I quite like just to work out some strange angle with a whole number value of k and just confirm that in fact it is a solution. So let's do just that. Okay, so I'm not sure how old you are. Maybe you're 17 years old. Maybe you're 18. Let's say 17. Okay, so let's go with 30 degrees plus 1440 times by 17. So according to us, 24,510 is a solution to this equation. 24,510. What we're going to do is we're going to take that angle and we're going to put it into the original equation and see if it gives us a half. 24,510. So the sine of 24,510 over 4, I'm putting it right into the original equation. We should get a half. Okay, sorry, we didn't get a half. Let me just check what I did over here. Maybe 30 plus 1440 times 17. It should have worked. We got 24510. 24510 over 4. Okay, right. So something has gone awry here. Okay, it is just as well we did check, because we've picked up an error, right? And the error that I've made over here is I forgot to multiply the 30 by 4. My apologies. So this should have been 120 plus 1440k. Let's bring our calculator back and try that one more time. Sorry about that. So 120 plus, I'm still going to go with 17. 17 times 1440. And we get 24,600. Let's check that. If we find the sine of 24,600 over 4, we should get a half. Whoopsie. Really making a mess of this. We should get a half, and there we do. Okay, my apologies for adding a bit of noise there with that. Okay, right. Let's have a look at C. Okay, so as always, the first thing we do is we find a key angle. Now our key angle, we're going to find the key by undoing tan of positive 3,2. Let's just see what that gives us. Shift tan of 3,2. And we get about 56,3 degrees. 56,3 degrees. Next up we say, which quadrants do we want to be in? Well, for tan to be negative, we actually want to be in these two quadrants. We get into quadrant number 2 by going 180 minus our key. We're going to get 123,7 degrees. 180 minus 56,3, 123,7 degrees. Now that, we can add 180k, because it's tan, we can add 180k, right? But remember, that's not our angle. This here, that's 2 theta plus 20. So that's not theta yet. That's 2 theta plus 20. So 2 theta plus 20 equals that. Now we're going to subtract 20 from both sides. We're going to get 2 theta is 103,7 degrees plus 180k. And now we're going to divide everything through by 2. We're going to get 51,65. So 51,85, I think. Plus 90k. Right, and remember k must be an element of z. I'm now second guessing myself. Let's just check. Is 103,7 103,7 divided by 2. 103.7 divided by 2. Okay, this is 103.7 divided by 2. We didn't want a fraction. 103.7 divided by 2. Okay, and in fact it's 51,85, so that was correct. Okay, all right, we are going to end the lesson here. Before the next lesson, we want you to try these 4 questions, right? For each of them, find the general solution and then find the specific solutions on the given domain. Okay, always a good idea to go via the general solution first. We look forward to seeing you next time. Have a great day.